Okay, so today we are going to talk about finding the average value of a function of two variables over a domain D in the xy plane. Okay, but first let's review single variable average value. And the notation for that, a common notation, is f of x star. That means the value of the function x, or the value of the function of f at some x value where the average value occurs. And we'll talk about average value over an interval from a to b. Okay, so the formula for average value in single variable calculus is f of x star equals 1 over b minus a, the integral from a to b of f of x dx. And what does this come from? B minus a is the length of the domain interval. Okay, so we want to take that idea and generalize to a function of two variables, okay? So instead of dividing by the interval of the length of the domain interval, what we're going to be dividing by is the area of the domain D in two space. So for a function of two variables, the average value of f of xy over some domain D, so f of x star y star, that's the point in the domain D where this average value of this surface occurs, equals 1 over, and this is going to be the area of D, times the double integral over D of f dA. Okay, pretty straightforward. So, all right, so let's do an example problem. Are you gonna? There we go. Okay, so let's let f of xy equal xy, and let's have D be a triangle with vertices. Let's go 0, 0, 1, 0, and 1, 3. All right, so I'm going to start by drawing a picture of my domain. So here's my x and y axes. Okay. And let's see. Okay, so this is y, x, and I need a 1, 0, and I need a 3 here. Okay. And let's draw our triangle. Okay, so we are going to have, oops, let's draw that a little bit better. There we go. And then going to the origin, and there we go. Okay, so there are our three vertices. And this region is D. Great. Okay. Okay. All right. So filling into our formula, it doesn't really matter what order I integrate in. One is not going to be easier than the other, so I'm just going to arbitrarily pick an order. Okay. Okay, so I'm going to, my formula for the average value of f of xy over this interval, domain D, this area D, is going to be 1 over the area of D. I have a triangle. I'm just going to do 1/2 base times height times the double integral over D, and I'm just going to do arbitrarily pick dy dx like I said. Okay, so if I have x's on the outside, my x's are going from 0 to 1. And my y's, well, my low y, this is y equals 0. And then my high y, this is y equals, well, I have a line through the origin with a slope of 3. So this is y equals 3x. Okay, so my low y is 0, my high y is 3x. I'm integrating the function xy, and I chose the order dy dx. Sorry. Okay, so what am I going to have here? I'm going to have 1 over 3/2, which is going to turn into 2/3. And then I'm going to have the integral from 0 to 1. Xy is going to integrate into 1/2 xy squared from 0 to 3x. And that's going to be 2/3 times, I'll stick my 1/2 out here, and then I'm going to have the integral from 0 to 1 of x, and I'm plugging in for y squared. So that's going to be 9x squared minus 0. So now I have 1/3, and then the integral from 0 to 1 of 9x cubed. And that's going to be 1/3 integrating, 1/3, 9/4 x to the 4th from 0 to 1, which is 3/4 times 1 minus 0, and the answer is 3/4. All right, so the average value of our function xy over this domain D in the xy plane is 3/4.